Alright, so now we're kind of basically going to do the last video for Project 5, right? Because at this point we've got our textures in a Mudbox, we've got them pretty much all plugged into Maya, and now we just need to kind of apply a few preset materials, which we'll do in a little bit, but we also need to light and render. Now, the way rendering works is basically we're just going to use the default camera that's perspective, but technically you can create, right, your own cameras. And you can have multiple cameras, and you can have your renderer render through them. But rendering is kind of like taking a picture, right? You're like, basically a camera, whether it's digital or more of a traditional camera. What happens is light gets let into the lens, right? The aperture of the lens, and it gets exposed either with digital cameras, the actual kind of little photosensitive sensors, right? But with film, it was chemicals, right? Chemicals on the film itself that they'd react with and create the actual photograph. Rendering works in a pretty similar fashion, right? It kind of takes the light as it bounces through the environment, right? And as the light rays bounce through the environment, they eventually make it to whatever camera you have rendering. That's called ray tracing. And what's unique about computer graphics, and it's actually really not that unique, it's kind of the way your eye works and cameras work, is the amount of actual light rays in the universe is an incalculable number, right? And almost none of those light rays ever make it to the cameras that we have on planet Earth or our eyeballs. So really all our eyeballs and all our cameras actually ever record is just the rays that make it into the lens or our eyeball. And ray tracing, basically in rendering for 3D, works in a similar fashion. It only calculates the rays and only traces the path of the rays from the camera back to their light sources for the light rays that make it into the camera. And that's what ray tracing does, right? Scanline rendering, which is the way a lot of games have been doing it up until, well, the new ray tracing 3D cards and the PS5 and Xbox One X series are actually going to have hardware ray tracing finally. That's nuts that video games are doing some basic ray tracing now. But scanline rendering is more like the scene looks at everything and it sees where the lights are at, where the objects are at, where the texture's at, and it guesses what the render should look like, and it renders it. Guesses can often be pretty good and make something look pretty nice, but things like metals, glass, shadows, those need to be more accurate than a scanline renderer can do. And so ray tracing actually, because it traces the actual path the light takes through the environment, can actually render things like glass and metal and the correct softness of shadows much more accurately, right? So pretty much all film and all TV do ray tracing now. Ray tracing is on by default. In fact, Arnold's renderer is not only doing ray tracing by default, but global illumination by default. I have never actually found where you can turn those off. That's how powerful rendering engines are now for film and just general non-game software, is that stuff's just on, right? But just kind of a little bit of heads up about what ray tracing is. Also, basically light works as ray and particle, right? The actual particle that carries light is called the photon. When you excite an atom, right, particularly all the atoms and whatever kind of magnesium, whatever kind of filament that's in the light bulb that's going to get heated, what happens is it heats up the atom and the electrons go crazy, right? The electrons that orbit the atom go nuts and they're kind of going out to their furthest orbit state they can, right? What happens is eventually that energy has to go somewhere. And so what eventually happens is those electrons kind of go back to their original orbit, the rest orbits around the atom, and that energy has to be released. And what happens is a photon is created. And that photon basically goes out on its own into the universe, and that is your particle of light, right? And it behaves like a ray, it behaves like a particle in certain instances. That's a whole Einsteinian quantum physics thing we really don't need to get into, but at least not for an intro to 3D modeling class, right? But basically that's what happens with light. So what you have is you have a direct light source, right? The real light. That's the actual object that emits photons. And what happens is that light source is the brightest, right? And that's going to create the most illumination on your objects. And it's also what's going to cast shadows, right? Because that's real light. So shadows will be cast because that object blocks that light in that area. It also affects the shininess of the object, right? That's actually where you'll see some of the specular highlights is coming from the light source itself. That's what we call a direct light. Some of you guys might be more familiar with that concept as key light, right? If you've actually just talked about it in a non-3D physics sense, for like drawing classes. It's a key light, right? It's your main light source. Now what happens though is those photons, they bounce around the environment, right? They don't just stop when they hit one object, right? They'll hit the wall and they'll bounce, and they'll hit the desk and they'll bounce. They'll hit the floor and bounce up underneath the desk. And that's what we call indirect illumination. Not direct illumination, but indirect illumination. You'll often hear it called fill light or bounce light. In 3D parlance, actually also, particularly if it's built into and supported by your renderer, which nowadays pretty much all renderers do, it's called global illumination. You guys might have heard of this in reference to video games also, because video games are starting to be able to do that as well, late in the PS4 cycle and definitely in the PS5 cycle. And what that is it's actually simulating the photons bouncing off of objects. This is one of the reasons why the Arnold renderer is so easy to use to get a pretty good renderer, because it actually does a lot of this stuff for you, right? So in this case, we're really probably just going to use one key light and just let Arnold do the bounce light for us. I just like to give you a little kind of heads up on some basic light theory though. So what you usually need is you need a key light, your direct light source that casts shadows, affects the specularity object, it's your most intense light. But then you need to put in some fill or bounce lights. In the case of Arnold, it's already going to kind of give us that through its global illumination system. So particularly in this project, we'll kind of keep it simpler. When we do render our character, because the environment's simpler, I usually kind of add a fill light to add a little bit of kicker. But there is direct light, your real light sources, and there's indirect light, and that's the bounced illumination. One thing about that fill or bounced or indirect global illumination is that it's more spread out and scattered, so it's less intense. It's also not concentrated enough to affect the shininess of an object or cast shadows. So if you put multiple lights in a scene that aren't key lights, you really need to make sure that your specularity effect is turned down to 0 for that light, and your shadow casting is off. And usually have the intensity be lower as well. And we'll talk about fill lights a little bit more on Project 6, because we're going to do a simple render for Project 6 also. But that'll build off of this lecture. So what we need to do is we need to actually start to set up our render and put lights in here, so then we can do our material presets as well. So in this case, you should see your kind of Arnold section up here, right? If you're not seeing that Arnold section, you can always go back to the earlier videos, but if you go to Windows, Settings, Preferences, Plugin Manager, you should be able to scroll down to the area that's, because it starts way up here. You should be able to scroll down to the M2A section, Solid Angle M2A. Make sure that's turned on. And that's going to give you your Arnold stuff. At this point, you should probably already have it turned on because you needed it to get to your Arnold standard surfaces also. But in Arnold, you'll see that there is an Open Arnold Render View, right? In the Arnold menu here, Open Arnold Render View. And what that's going to do is it's going to bring up your interactive render, right? That way you can adjust things and play with properties to see what's going on. Now in this case, we like to make sure it's on the perspective shape camera because we're just using the default camera. We do want to go to the render section here, and there's something called Run IPR. That means Interactive Photorealistic Render. So we can click on that, and you'll notice it's converting texture, so it's going through the render. But you're going to notice something once it's done that. It usually only has to do that the first time. Once that's in there, it's kind of in memory. It's in the RAM. Come on. There we go. Now you'll see, because of this camera view I'm in, I'm seeing no light, but I am actually seeing a little bit of reflection off the floor from the clock, and we are seeing the clock glow map emit light, right? So right now, that's the only light source in here. But because Arnold's got global illumination built in, your glow map is actually creating real light. Isn't that freaking cool? That's cool, right? But we're not seeing any other light because we have no other key light in here. Now, you notice we didn't bring a lamp in for this one because we just decided to omit that for this project. We didn't bring our ceiling fan in, but we're going to act like the ceiling fan's in there, right? And the ceiling fan has a light. So we're not actually even going to see that, but we are going to basically put a light in for that. So what I'm going to do is I'm going to close this down for the moment. So it'll be a little easier for us to put the light in. I'll zoom out a little bit. And in this case, I'm going to go create lights, right? And I'm going to use a spotlight because that's going to do a better job of mimicking the hanging light, right? Because that hanging light kind of has an edge, right? Where it's not emitting light. So these kinds of lights usually act more like a spot. And spotlights are basically cone lights, right? The light they emit out is a cone shape. You'll see there's other lights in here, like directional and point area. area is a rectangle of light, so that's good for kind of the lights we have at Cogswell, right? Kind of the big old rectangle lights, those neon lights you see usually in office buildings. A point light's a point in space, so that tends to be good for light bulbs. Directional light's actually parallel light rays. That's good for sunlight. You notice there's no key and fill in here. That's because key and fill are theories. They're ideas, right? Any one of these lights could be a key light. Any one of them could be a fill light, right? Because if you're using area lights, those are the kind of rectangle lights in office buildings. Those are key lights, right? And you could use directional lights as fill lights if you want to, even though if you're outdoors, you create a directional light for sunlight, and the sun is a key light. So key and fill are kind of concepts, not actual light types in Maya. So in this case, this spotlight is going to be our key light, our main light source. So in the Create Lights menu, Spotlight, we'll create a spotlight. Now it might be really small, so I usually hit R for scale, so I can scale it up. And now you start to see, there it is, and it's a cone shape, right? Now I'm going to hit W for move, so I can move it up. Now, the important thing is we want to keep it inside of the room, particularly the tip, right? So I'm going to hit E for rotate, right? So I can just rotate to point it down. And there we go. And now we've got a light here. But like I said, we want to kind of keep it in the room. It's in about the middle. It should be good. But we don't want the tip to be outside of the room, right? That'll do weird stuff. The light will cast shadows off the room itself, so it'll be really, really dark. So you want to make sure the light is actually inside of the room. The very tip at the top is inside of the room, right? There we go. So I'm going to zoom in a little more because we do want to make sure our camera's in here, right? And you can always take a couple of renders, like if you want to do a render from here and then a render from here if you need to kind of show everything off. I'd rather get a couple of renders if need be than just one that doesn't show everything. So if you've got your room laid out where I can get a shot that shows everything, awesome. If you can't, give me as many renders as you need to. You probably shouldn't need more than 2, but if you need 3, that's okay. We also want to make sure to zoom our camera in so that we're inside the room. That's important, right? Sometimes the camera can actually be outside the room and you'll see black when you render. So in this case, what I'm going to do is my light is still selected, and you'll notice attribute editor's on, right? And so you can see the light controls here. And I'm going to talk about those in a minute. But I'm going to go to the Arnold section here really quick, right? The Arnold menu up here. Open up Arnold Render View. We'll just make sure to tell it to run IPR so it'll update this. And you see it's updating it. And we can see the clock, so we know we're inside the room. But you'll notice we're still not really seeing that light, right? That's because of a couple of things. One, for whatever reason in Maya, the spotlight intensity, the default spotlight intensity is quite low, right? Really only for spotlights also. Like directional lights, it's usually fine. But for spotlight, you would need to turn this up to like possibly 10,000. So instead of using this intensity control, I go to the Arnold section, right? So I can go down a little bit further in the Spotlight attribute editor to the Arnold section. And in the Arnold section, you'll see that you have what's called exposure. And what we can do is we can start to turn this exposure up. And I might have to type in a number, like say 15. There we go. So if the slider maxes out at like 5, type in a higher number. Usually you can type in higher numbers for this. And now we can actually start to see this light affecting things. Now that cone's pretty small though, isn't it? So if we go back up to our other spotlight controls up here, we can turn the cone angle up. And you see how now this cone affects a lot more of the room? Now the edge of the cone's a little sharp, so what we do is we can kind of bring the penumbra angle up. Maybe even a little bit of drop off, although that's a little too high, so like maybe 0.5 for that. And that softens that cone. Now we can start to see light in the room. And you can even see bounced illumination, right? There's actually illumination under here. In this case, I feel like I need the exposure to be up a little higher. So I'm going to turn that exposure up to more like, say, 18. But you kind of try it with slower numbers, right? If you turn it up to 18 and all of a sudden it looks like you're on the surface of the sun, turn it down, right? If you didn't scale your room up to the proper size, exposure can affect those things, right? So if you're not getting exactly the same result, particularly with exposure as I am, try different numbers, right? Sometimes these numbers are relative. So don't freak out and go, oh my God, I turned it to 18 and it's not working or it's too bright. Turn it down or turn it up, right? Play with the slider. You notice how your Arnold render view updates, right? As we play with that, it updates itself, which is really, really cool. Because then we can start to see how all of these effects are working. And now we can actually start to see that we've got some lighting in this room. I'll zoom out a little more to see if I can see a little bit more of the scene. There we go. So there we go. You can see the wallpaper's looking good. We can see a little bit of reflection on the actual wood floor. And we can even see bounced illumination under here, right? If I was to rotate around to show kind of the desk, you'll see that there's bounced illumination under there, right? So the cool thing, and you can see this bounced on the side of the desk. So one of the cool things is that Arnold really does a pretty good job of creating that bounced illumination for you. Now, in this case, I've got some good stuff in there, so I'll save that really quick. And now what we really want to do is we just want to apply some materials, tinker with some stuff to kind of finish up this video. So in this case, what I'm going to do is I'm going to quickly assign a material to this guy right here. So I'm going to grab on that. All right, because that's our and you'll do this to any knobs and anything you'll have for that. So I'll even grab, say, maybe the knobs as well here, right? Because, we'll use the same material preset for those. So you can actually put the same material on multiple objects if you want to. So I'm just selecting the objects. I'm going to hold down the right mouse button. I'm going to assign new material. Here we go. I'm going to click on Arnold, AI standard surface. There we go. We got a new standard surface on there. And they're still selected. But you'll notice instead of going over to the material attributes over here, and remember you can always just hold that right mouse button, material attributes, right? You'll see the properties over here. Now, we're not going to play with any of these because we're going to use a preset. So in the same section, you'll notice there's an area called presets, kind of right up here at the top where you name it. There's something called presets. I can click on that, and here's presets. So there's chrome, there's diamond, there's brushed metal, just stuff besides non-metals, right? Glass, rubber. In this case, I think we're going to use, where is it? I think there should be, God, there should be a copper one in here. Let's see. Oh, there's copper. There it is. So we'll go to copper, right? And we'll just do replace, right? We'll do replace. And now you'll see there's now a copper material preset on there that's got metalness turned up, right? There's actually a slider for metalness in Arnold Standard Surfaces, guys. And now that looks like copper. Isn't that cool, right? So we could even go as far as maybe just selecting these polygons kind of on the top of this brass knob here, right? I'm going to go to face mode, and you can do this to all of them. I'm just going to select those top faces really quick. And what I can do is I can hold down the right mouse button, and I can actually assign an existing material. And I think it's I probably could have given it a name, but I think it was the AI Standard Surface 13. We'll check. What's going on there? Assign this material. I'm just going to do a new material for that. It's be easier. Arnold. AI standard surface. We need to run IPR again. Let me try that. What's going on there? That should be able to put a material just on those. That's acting a bit weird. We might close down that render and just bring it back up. Render view, run IPR. There we go. Now it's updating. Okay. So sometimes you might just have to close Arnold and reopen it up to get that to work properly. And then we can go presets. In this case, I probably could have used that original one, but we'll just use copper replace again. And there's that copper. Now, isn't that cool? And you notice that you can actually create or apply material presets that don't use textures at all. So certain things like really clean metals or glass don't need textures. They're just material presets with color, metalness turned up, specular really up, so you get that reflection. So keep that in mind, right? As you're kind of working with these things, that you can apply those material presets to anything you want to. In this case, I'm going to quickly kind of do one for the lower chair. I'm not going to use a preset though. I'm just going to probably use, hold down right mouse button, assign new material, Arnold, AI standard surface. There we go. And in this case, I'm going to turn that color down really kind of dark, right? And then what we could do is we could kind of bring that specular down a bit and bring that roughness up a little bit. And you see how that roughness kind of makes the shininess look a little more matte? And by bringing that weight down a lot, right, that becomes more subtle again, but it's less reflective, and it looks more like a plastic, right? So you can easily, you don't even have to use your own presets, right? Just pick a color you want and play with some of the specular controls, and you can get a simple kind of plastic for that lower part of the chair. Make that a little darker. And you see how as we turn roughness up, that specular becomes kind of more matte or less matte. So you see how roughness really kind of controls the matteness of the specularity. And of course, we can go back and we can adjust certain other things, like I'll show this on the chair here. The bump you see is actually quite subtle on this, right? Very subtle. So if I click on the object and I hold down the right mouse button to go to material attributes, you'll see that we can actually go back into the material attributes of the chair. We can scroll down to the bump mapping section, click on this. Now it takes us back to the exact image, right? But you'll see that there's these little buttons up here, kind of where the preset area is at and the file name. And this one right here can go back up one, right? So this can kind of go up and down your nodal network, right? So once again, just hold down the right mouse button over the object, material attributes. Remember, it opens usually up here, but if you scroll down, there's the geometry area, bump mapping. Click on the black triangle. It takes you to where you can put the texture in, but this little guy right here, kind of a box with the white triangle coming out of it, you click on that and it takes you back up one. And you notice we can turn the bump depth up to make the bump depth stick out more. But you notice how the actual real-time viewport and the render don't even come close to matching? The render is what matters. But you see how you can actually control the depth individually here? Now the nice thing is you can turn this slider up higher, right? If I wanted it to be 10, we could do that. And it becomes even more intense. That's a little too intense, so I think 5 was actually pretty good. But you notice you can actually type in your own numbers. So you can easily come in here and adjust your material property. You can turn your bump depth up, right? You could apply material presets. These are kind of all these fundamentals that come into this. So I'm going to close this. And what we're going to do is we can quickly, what am I thinking? Quickly I can show you just how if we click on the hypershade here, right, that blue ball, there's a lot of materials in here now, including our chair materials, right? So there's the chair, we click on it, and you have all your materials are here, including those presets we created. When we click on it, it shows its network here, but if you click on this one with the double triangles, you see how it shows you the whole shader network for the chair? The material itself, the bump, the color, the textures themselves plugged in. So the hypershade lets you kind of see the full network if you need to. Click on the different properties for that network to adjust here. And that's what hypershade does. Now the last thing we want to do is click on our light. I'll bring up the Open Arnold Render View again. Run IPR really quick. And I just want to kind of play with the shadow radius, right? So I'm going to make the shadow radius for the spotlight higher. What that's going to do is that's going to soften the shadow a lot. You might have to turn it up quite a bit to see the softness better. But it's going to soften the shadow as it goes away from the object, like real light works, right? So believe it or not, you can actually soften the shadow as it goes away from the object. And that's the way it works, right? It's harder at the base, but then where there's more light coming in from the fill, it softens the shadow. So turning up your radius in your Arnold section for your spotlight, right, controls the softness of the shadow. 0, there's no softness. You turn it above 0, it starts to soften it as it goes away. You can't turn the radius up too high. If your shadow disappears or looks like a bunch of dots, the radius is too high. Now that we've kind of covered all those things, I'm going to close this render down, right? And we can see this little kind of guy right here, right? It looks like those little clapboards, action. And it's got the eyeball one. I'm going to click on that. This is going to allow us to do the full final render. We want to use the Arnold renderer, right? We go to Options, Render Settings. And in the Comment section, we're going to scroll down. And we're going to pick the HD preset to be 1080. HD 1080. There we go. And then what we could do is we can click on this guy right here. And that's going to actually do the final render for us. So we'll give that a minute or so to kind of render up. There we go. And you notice this renders a little differently, right? It's kind of filling in each part of the render as it goes. So these are all completed when they're done. The Arnold render view we were using earlier is interactive. As you changed it, you saw it kind of updated, but it was kind of a little rough. And then as it went, it progressively refined itself and made itself cleaner. This is actually doing the final render by rendering each of these little buckets, right? These little squares. And once each of these squares is rendered, it's done, right? So this is going to allow us to get the final render. Even in that option render settings, we could turn the render resolution up to HD 1080, which is, your standard HD. And then there's just one more step when we're done with this here. So let's let it finish up here, and then we're almost done. Come on. You could do it. And like I said, if you need to do 2 renders to show kind of your bed and your desk chair, that's fine. 2 renders is fine. If everything's placed in the room, you can get it all in one render, that's fine too. But if you can't, 2 or 3 renders is okay as well. And in fact, that's what you'll be turning in, of course, is the Maya scene with everything in it, all the furniture, all in the same one master scene, all the UVs on everything. You do not turn your textures in. I repeat, do not turn your textures in. That's a lot of textures to turn in. You will turn in a couple of rendered JPEGs, though, as well, right? So you don't have reference images to turn this time, but you do have a Maya scene and the render JPEGs. So when this render finishes up here, I'll show you how to save it as a JPEG, color managed, and that'll be it for this video. Just gotta wait for it to finish up. It's getting really close. Getting really close. Come on, faster. But you see how this is looking way better than what it looks like in the viewport? And we can see shadows, we can see reflection, all of our textures on there, we can see the bumpiness. And this is what a render is. It's just your camera taking a picture of all of the information in the scene and the lights bouncing around. When it's done, in this render view, remember that was just this guy right here. You click on it, options, render settings, where you can go to kind of, pick your preset render, make sure it's using Arnold, and then run this guy and it renders it. And when it's done, there's no more blue squares, you're done. You go File, Save Image, and what you'll do is you'll change the file type from alias pics. Do not give me alias pics, guys. JPEG. We'll call this, you'll use the naming convention, but in this case I'm just going to call it final render, but I would use the naming convention, right? Your name, and just put final render. And we also want it to be color managed, because the default render in here is using a gamma of 1. So that'll be it. And that's how you do your final renders. There we go.